Now, this is the start of all of it, how the earth gets shocked and pulls turned upside down, and we'd like you to take a second, just sit right there. We'll tell you how it makes things stand up, like your hair. In electrons, which are inside out, I was born and raised. In wires is where I spend most of my days. Flowing, spinning, magnetizing all through it makes your phones all work, so yeah, it's pretty cool. And when you need to toast your bread or light up your room, just turn on the electricity and boom! And if you put your mind to it, it won't be hard for you. You can understand this type of energy too.
Hello, and welcome to this video. Today we're going to be learning about electricity.
You know, the thing that shocks you or makes your hair stand up? But there's so much more to this incredible aspect of our universe that is electricity, so stay tuned in to learn much, much more.
Electricity is a type of energy that enables us to power up our everyday objects. In each of the devices we use, electrical energy is turned into another type of energy.
Did you know that electricity has to go through metals? Certain metals conduct electricity. Other materials that don't are called insulators. Rubber is a common insulator, something electricity can't go through. It is used commonly on wires and other electrical equipment.
Hello, I'm Dr. Patrick, and today I will be doing an experiment exhibiting static electricity. First, put on my safety goggles. Alright.
When you rub a balloon on your head, the balloon becomes negatively charged. This is because your negatively charged hair is transferring electrons to the neutrally charged balloon. Now, when you rub the balloon on a metal ball, it transfers this negative charge onto the metal ball and into the aluminum foil strips. Since, like in magnetism, electric charges that are alike repel each other, the aluminum foil strips move apart in this demonstration. Electricity comes in different forms, sometimes moving, sometimes stationary. When electricity does not move, we call that static electricity. However, when electric charges do move, we call that a current. A current is the movement of either positively or negatively charged particles. There are many things working to keep this current flowing. A circuit is a path of wire or some form of conductor, which is a material through which electricity can easily pass. And it is through this path that a current can flow. One of the aspects of a circuit is voltage. Now, just as there's potential energy in a car at the top of a hill, there is potential electric energy in a voltage source. Voltage is a difference between electric potential energy in two places on a circuit. A voltage source is a tool which causes this difference to occur. As you can see on this diagram, the car has a lot of potential energy and not much kinetic energy at this point because it's on top of a hill and isn't moving. However, when the car is at this point on the track, it has a lot of kinetic energy and not much potential energy since it is moving and it isn't high up. As you can see, there has to be a difference in energy between two places in order for there to be any sort of motion. The same goes for electricity. Voltage sources create a difference in energy in two places on a circuit, causing the motion, or in this case, a current, to occur. Some examples of voltage sources are batteries. You can think of voltage as the force which causes a current to occur on a circuit. In a circuit, the more voltage there is, the more current there is. So, if you want to increase the amount of current, you just increase the amount of voltage you give the circuit. And while this is a way to add to the amount of current, there is also a way to decrease this amount. This is by a thing called resistance. Resistance measures how difficult it is for a current to flow through a material. It's almost as if you're measuring friction, except in a circuit. Resistance is measured in ohms, which is named after the German scientist who investigated this aspect of electricity. He found that the more resistance there is in an object, the less current will flow through it. This is a conclusion that can be drawn from Ohm's law. This law says that the voltage of a circuit divided by the amount of current equals the resistance. This is the relationship between current, voltage, and resistance in a simple series circuit. As you can see, if we put this equation into a magic triangle, we will find that Ohm's law also says that the amount of current equals the voltage divided by the resistance. So, if the voltage stays the same, but the thing it's being divided by, the resistance, increases, we can see that the end of result, the amount of current, will in fact decrease. This shows how more resistance leads to less current in a circuit. We've talked about what electricity is, and we've seen how it works in simple circuits, but now it's time to talk about its many different uses. Electricity is used to produce heat and light in many different kinds of machines. Some of the more commonly known ones, however, are incandescent light bulbs and heating elements. So let's talk about those. Incandescent light bulbs are exactly what you would think they are. Light bulbs which work by incandescence. But what is that? Don't worry, we'll find out soon. Take a look at this diagram here. In incandescent light bulbs, an electric current is run through these two wires up into a filament, which is what we call this thin coiled wire right here. The current is run, and eventually it heats up the filament to a very high temperature, one so high that light is produced. So there you have it. Incandescence is the use of an electric current to heat a filament up, so much so that not only does it produce heat, it also produces light. Now let's talk about heating elements. You may be thinking, what is a heating element? Well, it's very similar to a filament. Most heating elements consist of nickel or iron-based wire. These materials are either put into a coil or a ribbon, and the ribbon is either straight or corrugated. This is an example of a heating element. It's one that's commonly used in stoves. Heating elements work in almost the same exact way as incandescent light bulbs do. An electrical current passes through the filament, but this time it's the coil or ribbon of wire, causing it to glow bright red and radiate heat, just like you saw in the picture of the stove. However, the only difference between a heating element and an incandescent light bulb is that in heating elements, the filament is usually made up of a very sturdy material, one that doesn't melt easily, and it is bombarded with a much bigger current than one in the bulbs. So, there you go. Now you know how electricity is used to produce heat and light in everyday objects. Now, let's take a look at some of the cool properties electricity possesses. Electricity and magnetism are actually very closely related, so much so that there is even a branch of science dedicated to the study of the interaction between these two forces. This study is called electromagnetism. Electricity is essentially the movement of electrons. Now, electrons are these little negatively charged particles which float around the nucleus of every atom. When these electrons move, they do a bunch of different things, some of which include flowing and spinning. This movement, when electrons pass from one object to another, is called a current. However, when they stay in one object, it's static electricity. When electrons spin and flow, they also produce magnetic fields. Since spinning is a type of movement, this means that electricity is present as well. So the fact that electrons are moving is causing a magnetic field to be produced. In other words, electric currents cause magnetic fields. Did you know an example of this property is actually in the Earth's core, when high-speed flows of molten iron generate an electric current? This electric current is what produces the Earth's magnetic field. Now, scientists call this process of electric currents producing Earth's magnetism the dynamo effect. However, this isn't the end of how electricity and magnetism are related. When magnets themselves spin, the material's electrons spin with it. This also causes electricity because it's the moving of electrons. So, as you can see, the relationship between magnetism and electricity is kind of like a circle. Moving electrons, or electric currents, produce magnetic fields. Then, when these magnetic fields line up, they magnetize a material. The now magnet spins, and this motion in turn causes its electrons to move, creating electricity once again. Now, this is the main natural way that electricity is produced by Earth. However, there are some ways that mankind has produced the force, using some much different techniques. Fossil fuels are non-renewable resources. They are formed from the remains of prehistoric plants and animals which have been buried under rock for millions of years. The type of fossil fuel it is depends on 4 things. 1, the composition of the material present, the stuff that it's made out of, the amount of time it was buried, and pressure and temperature. Workers drill into the earth to find these fuels, the most popular of which are coal, oil, and other natural gases. The workers then burn the fuels to produce electricity and heat. Coal and oil are used to heat up houses, as well as power vehicles, manufacturing, and even electricity plants. Now, fossil fuels are very common because much matter has been buried underground for millions of years on Earth. However, while fossil fuels are very easy to find, they also cause large amounts of pollution. The burning of fossil fuels is extremely harmful to ecosystems and our atmosphere. In fact, 3/4 of man-made pollutant emissions come from the burning of fossil fuels. In addition, the actual labor of finding these fossil fuels can be very dangerous. Coal mining is an example of this, as there have been countless deaths related to coal mining accidents. Another way that mankind has learned to produce electricity is through the use of nuclear energy. Nuclear energy is energy released when atoms of certain materials are split. This form of energy is extremely useful in creating electricity, so much so that nuclear power plants provide 11% of the entire world's supply of electricity. This process of making electricity is reliable, as nuclear power plants are long-lasting and there are thousands of them all over the world. In addition, there are some positive effects on nature itself from using nuclear energy to make electricity. Nuclear power plants contribute to clean air and produce low CO2 emissions. Unfortunately, there are some negative effects as well. Nuclear power plants use up water from places nearby and return the dirty substance back once the process is finished. In addition, nuclear power plants also discharge nuclear waste. They come in barrels like this, which is incredibly harmful to the environment, as the workers have no place to put it, so they just dump it wherever there is space.
Hydrogen is only available at a handful of locations, mostly in California. It's currently in experimental use, but it stores the chemical energy of hydrogen to generate electricity without combustion or pollution. Wind and solar energy. Wind turbines can also use generators to convert wind into electricity. Solar energy uses the sun's energy. It gives off an all-natural electrical power. These are both expensive and it depends on the weather.
Heat is a form of energy. This type of energy is transferred between two objects of different temperatures. It is associated with the movement of molecules and atoms in a material. The more movement there is, the more heat is produced. In machines called thermoelectric generators, heat is used to produce electricity. The way that this happens is there are millions of electrons zooming in the machine, and one end of it is heated. Since the electrons are heated on one end, they zoom across to the other end to get away from the heat. Now, because the electrons are moving, this creates an electric current. So, heat heats one end, the electrons move, creating an electric current. Heat is producing electricity.